Hey, welcome back to part 2 of the Spring Data Redis tutorial. In part 1, we talked about the project we're building, a to-do application. We also explored the Redis data structures that we're going to be using. And in this episode, we will jump right into building and creating, configuring our Spring Boot application, and also exploring Spring Data Redis.
With me, Brian Sambo.
Right in the corner.
Now it's time for us to start playing with the Java side of the equation. And we're going to talk about Spring Initializr first. So I'm trying to make no assumptions about your level of proficiency with Spring and drop some hints and suggestions along the way so you can be more effective at your Spring development adventures. So Spring Initializr, yeah, it's not a typo. Somebody got cutesy with the name. Looking at you, Krispy Kreme. And basically nowadays, if you're going to start a brand new Spring Boot or Spring app, you will use Spring Initializr. And what is Spring Initializr? It's pretty much the easiest way to get a Spring Boot app skeleton created. It's a web-based form that allows you to select what you need in this skeleton app, and it will generate a downloadable zip file for you. And you can also share that configuration with other team members or friends. So the Spring Initializr will ask you to select between Maven or Gradle. Then you will pick the language that you want to use. Currently, they have Java, Kotlin, and Groovy. You can choose your Java version. I've been, by the way, using Java 11 for all of my tutorials at this point. And then you can pick your dependencies. And after that, again, you can generate your zip file or share a query string for the Spring Initializr website to actually share with teammates. So this is kind of what the Spring Initializr page looks like after you pick some dependencies. This was a screenshot from when I was creating the base for this tutorial. And now let me actually show you this on the actual browser. So here's my Spring Initializr page. What I did, it's actually on the README of the project, I put a short URL that will basically load the configuration as it was when I created it. So I usually rename some of the generated files in the project after I create the skeleton with Spring Initializr. And obviously there will be changes to the dependencies in the POM to facilitate certain things, especially once we get into the world of developing the React application embedded in our Spring Boot project. So now let's talk about how we're going to talk to Redis from our Spring Boot applications. In Spring Data Redis, we have several capable Java drivers available. Two of the most popular drivers are Jedis and Redis, and Spring Data Redis supports both of them. So for this tutorial, we will use Jedis. To do so, we need to add an exclusion to the Spring Data Redis dependency in our Java Maven POM. And so to pick out Redis out of our dependencies, we need to modify the Spring Boot starter data Redis and add an exclusion for the Redis score dependency. And I'm also adding the Jedis dependency under that. All right, so let's talk about Spring Data. Spring Data, it's an umbrella project that provides a data access abstraction layer over many different data stores. Both SQL and NoSQL data stores are covered by Spring Data. One of the main concepts in Spring Data is that of repositories. And repositories are DAO-like interfaces, data access objects-like interfaces. In their actual Java interfaces that you extend and add your own specific methods, and they don't really require an implementation. What happens is under the covers, the underlying framework proxies the calls to your DAO, and based on the method in the method signatures, it will basically provide an implementation under the covers. So there are store-specific implementations for most of the available data stores out there, including Redis. In Spring Data Redis, it's that implementation. The two interfaces that we are going to be mostly, actually, we're going to be interested today only in the CRUD repository interface, which, as the name implies, it provides a create, read, update, and delete interface to a Redis data store. Spring Data Redis, it's a specific implementation of the Spring Data interfaces, some of them, to abstract access in data mapping against Redis. So Spring Data Redis, it's a module that provides easy configuration and access to Redis. It has the ability to select the low-level connectivity. It also doesn't hide that. You can actually use a low-level connectivity if needed to via Jedis or Redis. As we did previously, we are choosing Jedis for today's tutorial. And it also provides the concept of templates. And a Redis template is a high-level abstraction for Redis operations. All right, so before we start fleshing out the application, let's take a look at the bones provided by the Spring Initializr project. As you can see, I have my code editor open, and let's take a look at the directories that we have at the top level. We have a bin directory for the compile artifacts. We have a data directory. It's an empty directory that I put in there for Redis to keep our data locally. There is the submodule for the JS specs for the to-do backend project. And then we have our source folder with the typical Maven folder structure. So we have a source main Java. Under that, we have a to-do application. Let's take a quick look at that. As you can see, it's a bare bones Spring Boot application. We have the @Spring Boot application annotation on our class to-do application and a single main method to basically launch the whole thing. Under resources, we have an empty application.properties file. And on the testing side, we have a to-do application tests that also is lacking any tests. So this has a very basic context loads test that does nothing right now. We won't be using this test file, but we will have a controller-specific test file. Finally, there's the Docker Compose that we've seen before to launch our Docker instance for Redis in our POM file. And in the POM file, we have what Spring Initializr has given us. Java version, it's 11. We have the exclusion for Redis. And then we have some other dependencies like TimeLeaf, the Spring Boot Starter Web, HeyTOS, the dev tool so we can reload the application easily. We have the Jedis client and Apache Commons Pool 2. I'm also using Project Lombok so we don't have to type so much code. Lombok will basically give you the ability to generate getters, setters, and builders, toString, equals, and hash code implementations at runtime. And I'm sorry, not at runtime. That is a bytecode generation, I believe. All right. I also added a folder to be included, which is the source main web app, and that's where we will put our React.js application once we get to that point. All right, so let's talk about how we connect to Redis. And for this, we're going to need a Redis Connect config, and we're going to also have an instance of our Redis template available to our application. So let me switch to the code. And as you can see, I have the to-do application.java open. And now we have added the enable auto configuration. And now we have a bean included in our to-do application, a bean annotated method. So our method returns a Redis template. Notice that it's parameterized to question marks. And we create our template. And we set the connection factory to be the connection factory. And then return the template. In the application, the properties, I've added the Spring Redis host, which is our local host, and the Redis port, which is the default 6379. I also added a Thymeleaf cache set to false. So once we get to the React application, we won't have to stop and restart the application if we change any of our templates. Now will be a good time to actually start our application. So we're going to switch now to the terminal. And on that terminal, first thing I want to do is check my Java version, make sure that I am on 11. Yes. And by the way, I use SDK man to control my Java versions. And you can put a nice SDK RC, I believe, file on your project so you can switch to the right Java version for the project. Highly recommend it. Now, let me launch the application with the Spring Boot run command using the Maven runner. So let's get that going. This might take a little bit of time since it's the first time we're building. So you can see the build, it's pulling down all the different dependencies, configuring all the plugins, launching the Spring Boot agents. You can see the familiar Spring Boot banner scrolling by. And now we have our application waiting to be interacted with. The only problem is that we don't have any way to interact with it right now. But this is a good sanity check to make sure that our application is up and running. Our application, the main model, is extremely simple. It consists of a single POJO, aptly named to do. The main Spring Data Redis feature we'll use here is the @redis hash annotation. Say that twice. Let's take a look at the Java source code for todo.java so we can see what's going on in there. All right, so here we go. The todo.java, it's a simple POJO. I have a lot of Lombok annotations because we want to save ourselves some time and keep the legibility of the code high. So we have an all arguments constructor, a no arguments constructor, getters and getters generated for every method in the, or every property in the class. I have a builder, which gives you a builder API to build instances of your object. And finally, we have the star of the show, the @redis hash annotation. So notice that our to-do object has a few fields. I use the names that are being used in the to-do backend specification. I probably would have chosen different names for some of the fields, but that's what we're going to go with. So we have an ID, which I chose to be a long. You can use different types of IDs. Long, it's one of the ones that will automatically work well with Redis. And for that, we use the @ID annotation, which comes from Spring Data annotation ID. Then we have a string title, which is basically the text of our to-do. We have a Boolean called completed, which represents whether the to-do has been accomplished or not. We have a order, which is a long, and this, I imagine it's meant to indicate the order of the to-do in the list of to-dos, but there's no tests for this ordering in the to-do backend specs. And there's also no features in TodoMVC to change the ordering of the to-dos. So that might be something we'll do together later on as a refactoring of both of our back-end and front-end parts. Finally, there's a URL, which is kind of a lightweight version of HeyTOS. Basically, when you retrieve a to-do, the expectation is that there would be a URL field that points you back to that to-do itself. So basically a URL to the get to-do of our API. All right, so now we have a to-do model, and we are going to need next a to-do repository. The to-do repository is going to be our bridge to Redis. So let's quickly take a look at what an implementation of the to-do repository would look like. And as you can see on screen, I have the to-do repository implementation, or interface, actually. There's no implementation. We're saving ourselves a hell of a lot of typing because Spring Boot provides a built-in repository called CRUD repository. Noticing here that I am extending CRUD repository, which comes from Spring Framework Data Repository, and I am typing that repository to be a repository of to-dos. Obviously, CRUD repository is a create, read, update, delete repository, which contains all those methods for us to interact with an object. In the second parameter is the along, which represents the primary key of our object. So notice that basically this is all we have to do. At runtime, those calls to the to-do repository would get intercepted by a dynamic proxy that will then basically craft the correct calls to the CRUD repository Redis implementation under the covers, and voila, everything works. So the CRUD repository provides a very nice list of pre-implemented methods for you. There's a count method to count the number of items in that specific repository, so how many entities, how many to-do entities we have. There's obviously a delete all, a way to iterate through a list of entities and delete them. There's a delete by ID, exist by ID, find all by ID, and obviously the ones for saving all entities being passed. So now let's talk about how to put some data in the database so we have something to play with initially. So on screen, there is a snippet of code of a method annotated with the @bean annotation. And it returns a command line runner. I aptly named the method load data, and it takes the repository as an argument. And this is a functional interface, so in here we can return a set of actions in a Lambda against that repository. So notice that in here we're first doing a delete all, so we're basically flushing out our set of to-dos every time the application restarts. This is convenient in development, but again, if you leave something like this around, it might be surprising for people running the application in production. So this is only for development purposes. Keep that in mind. After that, I have three to-dos being built using the Lomdoc provided builder, and I'm saving each one of those to-dos to the database using the repository.save method. Notice that to build a to-do, you invoked the builder method against the to-do class, and then you can basically daisy chain a builder interface, basically that takes the name of the setter that you want to apply. So for example, title, wake up, and then I do a .build, and it's basically building that object for me with the title set to wake up. All right, so let's quickly switch to the code so you can see the whole thing in context. Now, in context now, our to-do application is growing. So we have the Redis template that we had before, and now we have our command line runner bean. Keep in mind that you can use the command line runner in many different ways. You can implement a full-blown class for that interface. But in my case, I decided to just provide a method that returns a command line runner instance and mark it with @bean. Again, remember that this is a functional interface, so you can use Lambda expressions in exercise, for example, like we did in here, some of the to-do repository CRUD methods. Remember that we actually looked at the CLI, and we looked at Spring keys. We also looked at sets and hashes. So we're going to basically do the same again, but in context of our application. Spring Data Redis will create a Redis set of primary keys. In our case, our primary keys are longs, so this is an example of a 3 primary keys for the data that we created with the command line runner. And the key for that set, it's constructed out of the full name, the fully qualified name of the class. In our case would be com redislabs.edu.todo.domain.todo. Now, the individual object instances are kept as hashes. On screen, it's 3 typical hashes for our to-do instances. They have the fields that we saw on the code, ID, title, and completed. Since I'm not setting the value of order, null fields do not get added to the hash. And that's one of the beautiful things about schema-free environments like Redis, where you can basically save space by not adding a property that it's not needed at this point in time. So these are kept in hashes. The primary key for those, again, it starts with the root of the class, the fully qualified name of the class, and then a colon in the primary key of the objects. All right, so now that we have an understanding of how the objects get mapped to Redis, let's switch to the Redis CLI and take a look at what our data loader has done. So back at the Redis CLI, I'm going to first, let's see what keys are available. So notice that we have 4 keys. We have one key for the to-do list of primary keys, and then we have 3 other keys for the individual instances, which are hashes. Let's ask Redis what the type of the to-do key is. So that's a set, and if we do the same with any of the other keys, we're going to learn that those are hashes. So let's quickly see what the members of that set are. And we'll use the S members to do that. Let's just take the primary key out of that. And you can see that the primary keys for the 3 to-do instances are returned by our S members against that set of PKs. And for example, if we wanted to see what the contents of one of the objects are, we can use the hgetAll, and then let's grab an ID. Let's say, for example, this one up here. And we can see that the list of values, it's obviously top to bottom, it's a key value. So we have the class, the special class metadata field it's added that basically tells you what the object contained in this hash is. So it's a to-do. Then we have our ID, our title, in the completed flag. Hey, thank you so much for watching. Join me for part 3 of this series when we will begin the test-driven development cycle to flesh out the to-do backend API. And give us a like by smashing that like button, and subscribe for more Redis, Spring, and general Java content.